Okay, so now you've seen the lesson on E and F. This is ending your Chapter 2 notes. Now let's look at the sample problems that go along with E and F. As you've noticed, like in C and D, you had to use specific kinematic equations, and as usual, what we want you to do is look at what are the variables that you are given and your variable that is your unknown, and assess which one's missing out of that. Like, is time missing? Is displacement missing? Is final velocity missing? And this should definitely help you to figure out which kinematic equation you want to use. Well, the title of sample problem E is final velocity after any displacement. So right there kind of lets you know that time is not going to be a factor. So think about a kinematic that does not have time in it, and that's the one that you should be applying to this problem. Let's read through and write down what our givens are. It says a person pushing a stroller starts from rest, so that would be a VI equals 0 meters per second, uniformly accelerating at a rate of, well, there's an acceleration, 0.500 meters per second squared. What is the velocity of the stroller after it has traveled, so that would be a delta x, 4.75 meters. So once again, what's the velocity after it has traveled? That right there kind of lets you know that it's a VF and not a VI. And then obviously, make your units match here. So if your initial velocity was meters per second, make your final velocity meters per second as well. Okay, so looking back at your kinematic equations, look through them real quickly, please, and find one that is missing time, but does have final velocity and displacement in it. So take a second and look. Which equation is it? The equation that you want to use here is VF squared equals VI squared plus 2A delta x. Now, luckily, the variable that we're trying to solve for does not need reorganized or isolated because it already is. Checking out your units, everything's meters, seconds, meters per second squared. So we're okay on units. We also do not need to convert anything. But check out that this answer, if you do not do what I'm about to tell you, will show you velocity, final velocity, squared. You want just final velocity. So what do you think we need to do to both sides of the equation so we can just get VF, guys? We'd like to take the square root of both sides. So if you do that, that leaves you with VF equals the square root of VI squared plus 2A delta x. All right, let's plug in and solve through. Get your calculators ready, please. So VI is 0 squared times 2. Your acceleration is 0.500. And your displacement is 4.75. So in your calculators, you should know what half of 2 is. Multiply that by 4.75. Don't worry about the 0, because obviously that's going to be 0. And then second square root, second answer, this guy. So take the square root of 2 times 0.5 times 4.75. Put that in your calculator. Let's see what calculator answer you get. All right, calculator answer should be 2.18. Looking back at your givens here, obviously V sub I does not count for sig figs. So looking at your acceleration, leading zeros never ever, lagging only with a decimal, that leaves us with 3 sig figs. Delta x leaves us with 3 sig figs as well. Well, the calculator answer is literally 2.18, so we're going to jot down V sub f equals 2.18 meters per second. Making sure that you box your final answer so that we know to give you points for your final answer. Looking at practice E problems, number 1 will have 1 answer, number 2 will have 3 answers, number 3 will have 2 answers, number 4 has 1 answer, number 5, 1 answer, and number 6, 1 answer. All of them are using your VF squared equals VI squared plus 2A delta x equation, but not all of them are solving for VF, so there will be a lot of rearranging going on in these problems. As noted before, make sure you check the end of the book for the answers to the odd problems. Let's move along to F. All right, sample problem F is talking about free fall, falling objects. So we need to remember to always put in G equals 9.81 meters per second squared. That's like the first given that you should write down so that you don't forget to write that given down. Usually that one is not even going to be listed in the problem. So let's just start off by writing G equals 9.81 meters per second squared. Okay, so the problem says Jason hits a volleyball so that it moves with an initial velocity, v sub I, of 6.0 meters per second straight upwards. That would obviously indicate a positive 6.0 meters per second. If the volleyball starts from, so our x sub I, 2.0 meters above the floor, how long will it be in the air before it strikes the floor? Okay, so what we will be solving for then is our time that it will take. I'm going to leave a little bit of a space here because there's something that I'd like to reiterate. Notice how it says xi. Well, really, although that is a displacement, we're really looking at yi. Why is it y and not x? Check the problem out. It says starts above the floor, so we're talking about the y-axis. So y sub I. So this thing is going 2.0 meters above the floor. But check this out, guys. It says how long will it be in the air before it strikes the floor? So we're talking about on the way back down. So if we're talking about on the way back down, that's obviously going to be a negative 2.0 meters. Once again, that negative implies direction, not a negative number. So from that in mind, we have our givens written out. Let's look at what equation would apply here. Well, this one you're going to have to use two different kinematic equations. The first one, we're going to use v sub f equals vi squared plus 2g delta y, because we're moving up and down now, not left and right. For this, we're going to solve through for v sub f, and then plug it into another kinematic so we can actually solve for time. All right, looking through for this, we would want to take the square root of both sides, so we're really using vi squared plus 2g delta y. Plugging in, this gives us 6.0 squared plus 2 times 9.81 times a negative 2.0. Questions? You should be pulling one out here. Since we are moving down, your free fall acceleration is a negative 9.81 as well. All right, plug that whole mess into your calculator. So 6 squared equals, second answer plus 2 times 9.81 times 2.0. Those negatives are going to give you a positive answer anyways. Okay, get that answer, square root second answer equals. On your calculator, you should see a negative 8.7. So this is going to give us a final velocity of negative 8.7 meters per second. That's not our final answer, so we're just going to star it. The next equation you want to use then, and I'll just switch colors here, is v sub f equals vi plus g times delta t. Rearrange this so that we can solve for delta t. So that would be v sub f minus vi over g equals delta t. Whereas v sub f is negative 8.7, v sub I is 6.0, and g is negative 9.81. This gives us a calculator answer of 1.498. From that answer then, looking at your givens, you only want 2 sig figs, and that 9 is going to round the 4 up. So your final answer is 1.5 seconds equals delta t. Box it, move on. All right, practice F problems. Number 1 will have 2 answers. Number 2 will have 2 answers. Number 3 will have 2 answers. And number 4 only has 1 answer because you don't have to go to time. Now for problems 1, 2, and 3, you'll be using the same setup as the sample problem here. Start with your VF squared equation, solve for VF, then use VF equals VI plus G delta T, rearrange, solve for T, box, and move on. So you should have a grand total of 2, 4, 6, 7 boxes for practice F problems. Once again, answers to the odds are in the back of your textbook.